students. Let's start today's session. We were discussing about timers yesterday, so we'll be starting from the timers. Okay, so we have seen this diagram yesterday. Okay, let me clear it a little bit up. Yeah. So this was the diagram, and we have seen that the main part of timer is this part. This is my actual timer. Okay, there are basically two resistors, 8 bit of two resistors, so combined it makes 16-bit resistor. And from here you can start and stop your operation. To start and stop the operation, you have two options. One is the software option, the other one is hardware option. We are not right now discussing about the hardware option, but in software option what you have to do is you are supposed to write this bit. This is TR bit. TR is timer run bit. If you write a 1 at this place, your timer will start, and if you write 0 at this place, your timer will stop. Okay, provided that you have gate bit set to 0. Okay, so your gate must be 0, then and then it will control from here. Okay, this is my oscillator, okay, where a crystal is connected. This is my division factor. For our example, all the example we are going through would be the division factor would be 12. Then this is my counter timer pin. Okay, but right now we are discussing about timer. That's why we'll select this CT bar equal to 0. So this is the name of the bit, CT bar. Okay, if you write 0 at the this bit, CT bar equal to 0, then your function would be as a timer, and if you write that bit to be 1, in that case it would be an counter. How counter works, we'll check it later on. Okay, but time being we are discussing about timers. Okay, so you have to write CT bar equal to 0. And this is my overflow flag, where I can check whether my timer has overflow. The desired movement has been there or not can be checked using my timer overflow flag. Okay. Now today we are going to write one program in which we will try to run the timer. Okay, and we will try to generate the desired amount of delay. Okay. So let's see that how what is the question and how we proceed in that question. Okay, so we'll be starting with the question first. So my question is, write a C program. Okay, now you can see the difference. I am writing here C program instead of a assembly level program. We will be writing C program throughout the course from this 8051. Okay, so write a C program to toggle LED connected to pin P1.3 1000 microsecond delay. Okay, question is, you have to toggle an LED. That's first thing. Okay, you are supposed to toggle an LED, but up to now we will having the question where you've been provided with either short delay or long delay type of question. So there you can use a for loop, but whenever this kind of specific question is that you have to provide the specific delay, immediately timer should be in your mind. That's the first point. Whenever the question is strictly saying 100 microsecond delay, that 1000 microsecond delay, that means you are supposed to use a timer. That's the first question. Okay, that's the first point. Okay. So by looking at this, I know I am going to use a timer. Now immediately as soon as I see this question, the thought is how I am supposed to use a timer. I don't know how to use a timer. Okay, so let's see that how to use a timer. Okay, we'll try, we'll go through like document first, then we'll come back, go here and go here so many times, and then we'll be finalizing our program. Okay, so we'll be kind of troubleshooting in this program. Okay? So let us start with this program. So very first line of the program would be, we know that we are supposed to handle this P1.3. Okay, so I know that my very first line of the program would be declaring P1.3 as an LED. So I'm going to do that using aspect LED is equal to P1.3. Instead of P1.3, what should I write? I should write P1 is 9 and 0.3 is 3. So 0x93. Then my void main will start here. My while one will be sitting here somewhere. Rather than writing program here, let's take this one. Let's take the program in your keyboard. So here we would be having 93. I will be having void main somewhere over here, and my while one will be somewhere over here. So this is my basic setup of the program. Now I don't know how to run the timer. Okay, so first let's see how to set up the timer and how to run the timer and how to check whether the timer has been completed or not. Okay, so very first question is this: how to generate 1000 microsecond? That's the first question. Okay, so to identify how to generate 1000 microsecond delay using timer, you have to do a calculation that we have done yesterday. So once again, I'm going to repeat that calculation. So we should be starting with my crystal frequency, but here in this question, crystal frequency is not given. So what I'll do, I'll first assume these things. Okay, so your answer would be like, your answer should look like this. Okay, first you are going to assume something. So assume crystal frequency is 12 megahertz. Okay, take this assumption whenever you have to assume frequency. Take this assumption. This would be the best assumption you will have. Okay, so assume crystal frequency is 12 megahertz. So this is my first thing. From this point, my answer will start. If you have been provided with the crystal frequency, then you have to use that frequency. But in this question, I am assuming it because it is not provided. So assuming crystal frequency of 12 megahertz. Now let's do some calculation. So we know that if my crystal frequency is 12 megahertz, my timer frequency would be, I need some response. My timer frequency would be, okay, so my F crystal is 12 megahertz. So what would be my timer frequency? We have done this yesterday.
1 megahertz, 12 by 12.
12 by 12. Okay, so why 12 by 12? Because we have this division factor here.
Division
So
factor.
divide this by division factor. The two options is available for the division factor. One is the 12 and other one is 6, but we will never follow the sixth one. So we always go with 12. So you have to divide it by 12. Just keep that in mind. Okay. So actually what you have to do is f of crystal divided by 12. That means 12 divided by 12. So you'll get 1 megahertz of frequency. Units are very important. Please follow the units. Otherwise you will be getting a huge error. Okay, so whenever you see some units, follow that unit system only. Okay, so this is megahertz, so my answer would be again megahertz. So f timer is 1 megahertz. So now what I have to find out is pulse time. Okay, one pulse time, or you can say t of timer. So this is periodic signal like this. So I have to find out this time. Okay, that would be 1 upon f. So t timer is equal to 1 upon f timer. So that would be 1 divided by 1 megahertz. So I am writing 10 to 6. Okay. So my answer would be 1 into 10 to minus 6 second. Okay, see, whenever there is hertz, so 1 upon hertz is your second. So if you have 1 upon hertz, it's your second. Okay, I have megahertz. So what I have done, I have done 10 to 6 into hertz. So it would result in 10 to minus 6 in second. Why? Because that is like 1 upon 10 to 6 into hertz. Okay, that's why my answer is looks like this. So it is 1 into 10 to minus 6 second, or I can write it as 1 microsecond. So this is my 1 microsecond. Now I know my pulse time. Now what I'm going to do is, once you know the pulse time, you know number of time delay required is okay. So now the time delay required is 1000 seconds. 1000 microseconds. Okay. So we are going to calculate the number of steps required. So we know that 1 microsecond is equal to 1 pulse, or you can say 1 count, or you can say 1 step, whatever you prefer. You can say either of this. What about 1000 microseconds? That's my question. So we know that we do cross multiplication here. So what would result in the answer? The answer would be 1000 microsecond into 1 divided by 1 microsecond. Okay, or the other way you can write it 10 to minus 6, 10 to minus 6. Okay, but that's fine, no issue. So I require 1000 steps, or count, or whatever you say, or you can say pulse, whatever you prefer, no issue. But mention something, then and then you can have the clear idea what you are doing. So I require 1000 steps. That's the first point. Now we have seen that yesterday. Okay, to reach this, like that example of the staircase where you have to reach at the finish line, that is on 10th point, and you are only given 5 moves. So what you will be doing, you will be starting from somewhere in between. Same way, my final number here can be 65535. And what I'm going to do with this number is, I have to manipulate the timer in such a way that after your 1000 steps that you require to have, after your 1000 step, your timer will reach at this point, and then overflow can generate, and then you can use that overflow to program other things. Okay, so we are going to do that. Now here, as soon as you find out this number, you have to take a decision. Okay. So this is the first part of the calculation. Now, as soon as you find this number, you have to take a decision. The decision that we have never discussed about, I am discussing it right now. Okay, so I have calculated the number. Now, there are various mode of operation. There are various modes of operation. We will discuss about modes of operation in detail later on. Okay, but what is a mode of operation? Uh, the option available with us is a 13-bit mode, 8-bit mode. How this work, we'll see it in detail. No issue. We are going to discuss all the modes in detail. But why this is important, I'll just letting you know. 16-bit mode and then split mode. Okay. These are the options available. There are this 4 options available. Now you have to select either of these 4. But how you are supposed to select, like what you have to select from this number? So your any of this operation can handle a large number. Okay, but the large number has the limit. Okay, for an example, if you are going with 8-bit mode, the selection would be 2 to 8 minus 1. So if your number is greater than 255, you cannot go with this mode. Okay, so for an example, this is 1000, so I cannot select this mode. Okay, same way for 13-bit, 2 to 13 minus 1 will result in, when I have to like 7000, somewhere around 7000, but I have to make sure that's the correct one. So let us calculate it. 2 power is power 2 power 30. 8192. Okay. So the other option is 8192. And here you have 2 to power 16 minus 1, that is 65535, and split mode again 2 to 8 minus 1, so you will be having like we will not do this. We will not do this. Split mode is something different, so let us not specifying this number. Okay. But you have these three options. Now, based on the question, you have to select either of these three options. Okay, and you have to clearly mention that which mode you are using. Otherwise, your program will change according with mode. Okay, so my personal suggestion, okay, do not go with this 13-bit mode. Don't go with this 13-bit mode until and unless specified. Follow this only and only if it is specified, and then the other two options you can follow according to question. For example, here my number is 1000. Okay, so 1000 is less than 255, correct? No, not correct. So I cannot select mode 8-bit. But here your 1000 is less than 65535. Yeah, is it correct? 65535. Is it correct? Yes, it is correct. Then I can select 8-bit mode. Then I can select 8-bit mode. Okay. So basically you have to remember this two number. You have to compare with this two number. If your answer, this number of step, if it is less than this 255 or 65535, according to that you have to make selection. For an example, if I have a 50, in that case I'll be selecting this mode only, 8-bit mode only. Okay. Why so? We'll discuss 8-bit mode in detail, and then we'll check why it is very important to select 8-bit mode whenever possible. Okay, otherwise you can go with 50 with this mode also, not an issue, because 50 is also less than like 65535. So you can either do one of this, but I'll suggest whenever it is possible go with 8-bit mode. Why? Because there is one important advantage when you use that mode. We'll discuss that advantage when we'll discuss that mode. Okay, so we have basically 4 mode of operation. Do not go with 13-bit mode until and unless specified, and go with 8-bit mode or 16-bit mode according to the answer. Okay, so how to select that mode? If your number is less than 255, I'll go with 8-bit mode. If your number is less than 65535, I'll go like it's in between 255 to 65535, then I'll go with 16-bit mode. So what's the possibility here? What's in our case? Quickly let me know. You can speak.
16-bit.
16-bit mode, correct? So I'll be going with 16-bit mode. So we have to mention it clearly, like I'm using a 16-bit mode. Okay, so I'll write it down. So this is how you are supposed to write in your exam. So whenever a question related to timer is asked, this is how you are supposed to write. Okay, that's why I'm writing these things. So let's write here. Make a point. As 1000 is less than 65535, we can use 16-bit mode. Now why this important is the other thing is, I have given you this example of staircase. Okay, so if you select a 16-bit mode, your finish line is 65535, and if you select 8-bit mode, your finish line would be 255. Okay, that's why it is important. One more point. So right now we know that we have selected 16-bit mode. That's why what we'll be doing, we'll be having this 65535 as my finish line. So now what I'm going to do, I'm going to calculate number to be loaded in TH and TL. Okay, so how to calculate that number? We know that number is 65535 is my finish line minus 1000. So my answer is 64535. Okay, so this is the number to be loaded in TH and TL. We know that number, but the issue is your microprocessor doesn't understand assembly like a decimal system. Okay? It always follows the hexadecimal system. So convert this number in hexadecimal, and then you can load that number. So I'm going to convert it 64535. Use your calculator. You can use your calculator. Go to programmer mode and decimal 64535. That is FC17. So actually, I am going to load this number FC17 in my timer register. So this is how you are supposed to calculate. Okay. Now where to load this number? So you are going to load this number in TL and TH. Okay. The lower part in TL and the upper part in TH. Okay. So 17 will be going to TL and FC would be going to TH. Keep that in mind. But right now I'm so 0xFC17 is my number. So this is the first step whenever you have a question of timer delay. This is the first step. This is the calculation. You have to complete this calculation. Then you can follow this program. So calculation is first step. Second step is a program. Okay. So we are done with calculation. Now I have all the numbers that I required. Now I can start my program. But before starting program, we do not know how to use a timer. So let's write set of instruction how to use a timer. Okay. How to set up the timer. Let's write down some set of instruction that you can use. Okay, let's write the instruction. Okay, so the instruction for setting up a timer. Okay, how to set up the timer? So very first is select the mode of operation. Okay, select mode of operation. Select your start method. And third thing that you would be selecting. Now, how to select this? That's also a question. Select mode of operation. Just I'll say that like select mode of operation, but how you are supposed to select that? So for that you have to go to your P89C51 datasheet. So inside this datasheet, you will see your timer. Show it to you. This is my timer and this is the register T mode timer register. So here you have to make a selection in this register. Okay, how to do that we'll see, but before that the third option is select timer for counter. You have to do this all these things at the same time. Okay, select mode of operation, select start stop method and select timer counter. So in this program what we are doing, I know my mode of operation is 16-bit. Start method, as we have never discussed about the hardware method, we will go with software start. And timer or counter. In this question, for this question I am having timer because I have to generate a time delay. Counter cannot generate a delay. Counter is something that can count, but timer is that can generate a time delay. Okay. So I want to select this 16-bit mode, software start and timer. Okay. One more thing that you have to select is, that's the very first step, is select the timer which you want to use. Not this one, it's timer which you want to use. Okay, so what are the options? We have two options. You have timer 0 and you have timer 1. There are two options. You have to select from these two options whether you want to select timer 0 or timer 1. Let's quickly go with it. Whether you want to use timer 0 or timer 1. Answer me. Whichever you want to use, I'm going to use that, and I'm going to demonstrate how to program. Which timer you want to use? Timer 0, timer 1?
0.
Okay, we'll go with timer 0 then. Okay, so for this question, I'm going to use timer 0. So I'm writing timer 0. Okay, so I know which timer I'm going to use. I know which mode I'm going to operate the timer. I know how I'm going to start or stop. And even I know whether I'm using a timer or a counter. So this timer or counter do not conflict with this timer and this timer. These two are different. This is the module that I'm going to use. This is the name of the module, and this is the operation of that module. Whether I'm like counting or I'm timing something. So I'm timing. That's why I have written timer over here. And this timer is all the different things. This is the actual module that's available in your 8051. This is the name of the module. Okay? Like there is no counter available separately, but you can use this timer itself as a counter. That's the option. So we have done the basic things. Now how to do this? Like I have written this, but how to set up these things? Let's check that how to set up this thing. Let me take it to this window. Yeah. I know I want to set up this. I need the other information, that is this value. Okay, I need these values. Okay, so let us see how I am going to do this. Go here. Okay. Now let's see how to do different thing. See, the first question is mode of operation. Which mode we are using? We are using 16-bit mode. Okay. So see here, using here M0 and M1. This here is M0, M1, M0, M1. Using this 2-bit, you can select mode of operation. Okay. Which are the mode of option available? See, this 808448 timer TLN server as 5-bit prescaler. Actually, read this as a 13-bit timer. This is a 13-bit timer operation. So if you want a 13-bit timer, if you want to select that, then what you have to do? You have to write your M0 and M1 00. Okay, so I'm going to write 00 over here. Then 13-bit timer is selected. What I want is 16-bit timer. So what I have to do? I have to write 0 in space of M1 and M0 would be 1. Okay, so how to do that? Let's check. So this is my register. So for mode of 16-bit, what I have to do? I have to write M0 is equal to 1 and M1 is equal to 0. Where I get this? I get it from this area. See this one. Where M1 is 0 and M0 is 1 for 16-bit. See, I have done that. Okay. Now, which timer you are using? You are using timer 0 or 1. So we have selected timer 0 for this program. Okay. We have selected this timer 0. So where I have to write it? This is my M1 and M0. So you have to write it here. So M1 is 0 and M0 is 1. Okay. Now let's check the CT. So we are using counter or timer. So we are using timer. So your timer would be selected if you write CT equal to 0. Where we have seen that? We have seen that in this diagram also. Okay. Or you can see it over here as well. See, timer or counter selector clear for timer operation. So when in examination you will be asked like explain T mode, then you have to write like this. But for programming method, just remember this. CT would be 0 for timer operation and CT would be 1 for the counter operation. Otherwise, for examination point of view, this can be a question. Draw the structure of T mode register. So you have to draw this like this, and then you have to write these things. Okay, you have to write these things like this. Okay, symbol and function. So what's the bit name and what's the function of that bit? Okay, so here your gate is repeating, so you are supposed to write it only once. No issue in that. Okay, CT is repeating, no issue. But you should write it like this. Okay, timer or counter selector clear for timer operation. See, it is written clear for timer operation. That means CT bar equal to 0. Clear for timer operation. That means you have to clear this bit for operating as a timer. So what it will do, it will take input from internal system clock. Yeah, is it correct? See, if you look at here, when you write CT equal to 0, we are connected over here and you are taking the internal oscillator as an input. So it is correct. When you write it 0, it takes input from internal system clock. Set for counter operation. That means if you want your counter to be operated instead of timer, you want a counter, then you have to write it 1. We'll discuss about it later on. So right now it should be 0. Then your last bit that is remaining is gate. How to select gate? So it's written in very complex language. Okay, so let's read it. Getting control when set. Timer counter N is enabled only while ILD pin is high and TRN control pin is set. When clear, timer N is enabled whenever TRN control bit is set. You should write it like this in examination. But actually, what does this lines of like that line means is if you want software control. Okay, so what is a software control? You will be controlling a timer through a program. That's a software control. Okay, and what is a hardware control? So actually through one physical pin on some external event. Okay, on some external event you are calculating the like running the time. In that case you can have the hardware. Okay, so actually when you use hardware method at that time, you will be setting some pins high or low, and due to that your timer will start or stops. Clear? So right now we are only going to use a software method. Okay, it is already the software start. So how to select a software start? So for software start, your gate should be 0. If your gate is 0, then it is a software start, and if your gate is equal to 1, then it is your hardware start. So we need a software start. So what I'm going to do, I'm going to write gate is equal to 0. So gate equal to 0. So this is my gate, so I'm going to write it 0. Now I am not using timer 1. So what I'll do with timer 1? I'll do nothing. I'll let it be 0, 0, 0. Okay, why? Because I am not using it. If you are using it, you have to set it up along with this. Okay, so this is known as timer configuration, and this task has to be done once. Okay, has to be done once in a lifetime, not lifetime, like done once. So this is a timer configuration, and timer configuration has to be done only once. Once you set it up, it will be in this mode, and this operation and this start method all remain as it is until and unless you change it. So this is the task that has to be done once only. That's why we'll be writing this before while 1. So now what you are supposed to write? That's also a question. So you are supposed to write this number in your register. Which register? This is the name of register, T mode. So you are supposed to write in T mode. So you will be writing like this. T mode is equal to, this is 0 and this is 1. So you are going to write 0x0. This is the binary number of 0, 0, 0, 0, 0, 0, 0, 1. Okay, this is hexadecimal from this binary. Which is what is this binary? This is this binary that we have just written. How we have written this? For mode of operation, we are 16-bit mode. That's why we will write 0, 1. Okay. For other modes, what you have to write, we'll discuss it whenever that mode comes in. Then counter or timer. So we are using a timer. That's why I have put a 0. And software control or hardware control. Software control. That's why I'll put a 0. And not using timer 1. That's why I'll put all zeros. Okay. If you were using timer 1 instead of timer 0, what you should be doing is this. Okay, so in that case I'll be having T mode equal to 0x10 and not this number, but we are not doing this right now. So okay, so this is how you configure your timer. What we have done by writing T mode equal to 0x01, we have done 3 tasks. First, we have done the mode of operation. So by writing 01 over here, you have 16-bit mode. By writing 0 at CT bar, you are operating timer in timer mode. And by writing gate equal to 0, you are selecting software start and stop method. Okay, that's 3 things that we have done using single register T. So let's look into the program, how to write this program. So what I will be doing, I will be writing it before while 1, because this task has to be done only once in a operation. So first task is done. T mode equal to 0x01. What should be the second task? So okay, so we are done with this. Now what should be the next step for running the timer? So load the timer according to required delay. How to do that? Load timer according to required delay. How to do that? We have done that already. This whole calculation is about that. So this is my number. I know that 0xFC17 is my number. So what I'm going to write? I'm going to load this number 0xFC17 in my timer register. Which are the register? If you are working in 16-bit mode, then there are two registers. Even if you are working in 8-bit mode or 13-bit mode, there are basically two registers that you are going to operate. Which two are that? That two register is THN or X, whatever you say, and the other one is TLX. Okay. So you are supposed to write in this two register. I write N, both should be N. If I write X, both should be X. Now, as we are using timer 0, so 0 itself represent your N. Okay. So actually where you should be writing is TH0 and TL0. Why? Because you are operating on timer 0. If it's timer 1, then you will be writing it TH1 and TL1 instead of this. Okay. So what I'll be writing is TH0 is equal to 0xFC, the higher byte, and TL0 would be my 0x17. This is the two lines of code that would be required. Now, does this code require only once? So as of now, it should be done only once. We'll see later on what happens. So TH0 is equal to 0xFC and TL0 is equal to 0x17. We have loaded the number in the timer also. Now what's the other step? See, now we'll go to the figure. See here, what we have done. We see now. Let's check what we have already done. What steps we have performed. Whether we are ready to run the timer or not. Let's check that and then we'll try to run it. First thing that you have done is you have selected gate is equal to 0. Okay, so that means you have selected 0 over here. So that would be resulting 1, and I have 1 at this point. The second step, you have selected CT bar equal to 0. Okay, that means you have selected timer. That means your input would be from internal oscillator. So this would be the line where my input be coming from. The third is you have operated 16-bit mode. Okay, how you have done that? Like what you will be doing it? Actually, when you are operating in 16-bit mode, at that time, here it would be 16-bit, not 16-bit. Here it would be 8-bit. Combinedly, it makes 16-bit. So this is my 8-bit and this is my other 8-bit. Okay. So what we have done here, we have put 0x17 over here and 0xFC over here. Okay. So now actual diagram is not like this. Actual diagram, if you want to draw, you can draw it like this. First is TL and then this TH. Why we draw it like C 0xFC17? If you increment it by 1, you will get 18, 19, 1A, so forth. So like you will get FF somewhere at some point of time, and then your FF would be the number. And then if you increment it by 1, what will happen is FD00. That means this 1, due to this one, a carry will transfer from lower byte to upper byte. Okay, this is my lower byte and the carry is transferring to upper byte. So actually first your TL is incrementing. Okay, which is incrementing? See, where is this? This is in TL. So TL is incrementing, and when TL overflows, at that time my TH will be incrementing by 1. So this is FC, this is 17. Okay, so 18, 19. Once it's reached FF, it will reset 0, 0, and then it will transfer a carry over here. So that carry will result in FD. Okay, same way again it will go from 0 to FF. Again a carry will be transferred, and once this one reach FF, okay, both reach FF, at that time what will happen? A carry will generate from here. Okay, it will set to 0, 0. A carry will generate from here to here. Again it will set to 0, 0. one more carry will go away, and that carry will be transferred to your TF, timer overflow flag. This one. Okay, that's why we have written TL first and TS later. Okay, so like please do not consider it like TL is first. Like number is 17, FC is not the correct way to read the number. The number is again FC17 only because we have calculated it. But as the nature of timer is in such a way, that's why we are writing FC first and like 17 first and FC later on. So this is my numbers. This is my 0x17 and this is my 0xfc. Okay. Now let's see whether timer is running or not. But to run the timer, what you have to do? You have to run the timer using this bit. But first, let's check what are the other setup. Other setup is ready or not. Okay, you have incoming frequency from here. Okay, that's good. You have your number loaded. Okay, so if you have this number, after 1000, what you'll get? You'll get your overflow flag. Okay, everything is set up. Now I can run my timers. Okay, so the next step is to run the timer. So let's write down the next step. That is run the timer. How to run the timer? By writing trn equal to 1. Now the next question is where is trn? How I am going to operate the trn? So let's see where is trn. So trn is the part of other register that is known as tcon. Okay, so this is the tcon and here you have trn. Okay, this is my tr0 and tr1. As we are using timer as we are using, let me take it Control C and I'll take it over here. See, what I want is timer 0 run. We are using timer 0. Throughout this program, we are using timer 0. That's why instead of trn, what I will be writing is tr0 is equal to 1. That means I have to write 1 at this place. What about the others? So you are not supposed to modify this. So let it be 0. You are not using timer 1, so 0. Not using this, not using either of this. You don't even know what is this. So write a 0 over there. What is the number? What is the name of this register? This register is tcon. The number is 0x. This is 0001. So that is 1 and 0. The number is 10. So if you write tcon equal to 10, you can run your timer. Okay. Run timer by modifying tcon register. Okay, which part of tcon is trn? This is the first method how you can run your program. So let's check that. So what I'm going to do is tcon is equal to 0x10. Okay. Now there is other method to do this. There is other method to run the timer, and what's that method? Let's check that out. How I know that? I know that from this list. If you look at closely at this box, you see some information over here. Okay, so what is this? This address is 88. What is this address? This is a special function RAM address. Okay, for port 0 we have 80. Same way tcon is on 88, port 1 is on 90. Same way address is, so this is my SFR. That's why it has a specific address. Okay, so if you want, if you look at this address is associated with bit addressable memory, and here it is written also bit addressable. But if you look at the T mode, then you can see not bit addressable. That means if you are using this T mode register, then you have to modify all the bits. That means you can only operate on T mode. You cannot directly at M0 equal to 1. It won't work. But here, if you look at this one closely, this is bit addressable. What does that mean? That means I can directly modify this bit without even touching this bits, provided that I know the address. So what would be the address? So do not worry about the address. That's the first thing. Okay. You just have to remember the address for port 0, port 1, port 2 and port 3. The rest of address can be taken care by something called as header library. Okay, we are going to add that library, okay, in a moment. But how I should write it? So you can directly write this name. Okay, so instead of modifying all the bits of tcon, what I can do is I can directly write tr0 equal to 1 and it will work. Okay, so instead of that, the other option is you can directly write tr0 is equal to 1. That's the other option. This is in bit addressable mode. See, when you write this, that is bit addressing mode, and when you write tcon, that's byte addressing mode. Okay, so you can see here this is 8-bit number, and this one is only single bit. You are writing tr0 equal to 1 and it's doing the task. So this is a single bit. Okay, so that's the reference. So I suggest that don't follow this method. Okay, you are messing up lot many things without knowledge. That's why don't follow this method, but instead of follow this method. Okay. So what we are going to do is we are going to run timer by modifying bit tr bit of tcon. In our case, as it is timer 0, that's why we'll write tr0 equal to. Okay, clear? So now we are running the timer. Now let's check what happens if I do this. Okay, now I'm going to run this program and let's check what happens. See, as soon as I press F7, there is lot of undefined. It does not know what is T mode. It does not know what is TH0, what is TL0. So one method is you can do this. You can write SFR T mode and then you can write address. But in that case, you have to remember lot many addresses. So there is the easy way. There is one header available that contains all this information. Okay, so I'm going to include that header. So include the header name is reg51.h. This is the name of header. Okay. So add this header and your error will be gone. See, again I'm pressing F7, 0 error, 0 warning. So what's inside there? What's inside there? Like how it is working? So let's go. Okay, I'm right clicking on it and open document reg51.h. And it opens the header file, and if you look at here you will find out your TL0, your TL1, TH0, TH1, T-mode, Tcon. Other than that, lot of registers are declared. That means all the SFRs are declared inside your rg51.h. So if you are using this, you do not have to worry about these addresses. Even ports are declared, so you are not supposed to write P0, P1, P2, P3. But this part, LED or like when you use port pins, that is not declared inside here. That's why you have to write it separately. Other than that, if you look at this tcon, so this is my TR0. See, it is already written over there. Okay, so you do not have to worry about that. So just include that header and you are good to go. Now, if I run this program, now let's run this program and check what happens. Okay, so F7, I'm going to debugging mode. Okay, now as I'm working on timer, I need timer. So let's go to peripheral, timer and timer 0. Okay. See, right now it is in 13-bit mode. It is in timer, tcon values, th0 value, tl0 value, tmode value. Okay, if you are not able to do it, read it. I should magnify it. Okay, so see, it is a 13-bit timer counter, timer, tcon 00, 00, 00, 0, 0, 0. Okay, everything is 0 right now. Okay, so now let's go here and I'm going to single step this thing. So see, as soon as I press this button, what happened? Tmode equal to 0x01 executed. You can see here now tmode equal to 0x01 and here mode is changed to 16-bit timer or counter. Okay. Other than that, what happened? It has also known that what's the method of running. So gate is set to 0 and your TR0 bit is 0 right now. Now the second step is TH0 and TL0. I am going to load the value in TH and TL. Okay, so let's do that. Yeah, okay, it is visible. So FC17. Okay, FC17. Now as soon as I write TR0 equal to 1, it will start running. The timer will start running. Okay, now let's check that. See, now you can see your TL0 value is incrementing. So internal timer is running and that's why it is incrementing. If I run this program throughout, it will go like this. Okay, but you can see Meanwhile, at some point of time, your TF0 is set. You can see. I'm going to reset it, and I'm going to again check that. Okay. See, if I run this, at that time TF0 is not present. But if I run this continuously, your TF0 will set. Okay, look at closely. See, that means the TF0 is indicating that your 1000 microsecond is completed. But I do not have any line in the program that check or monitor the status of this TF0. So I'm going to do that by writing one more instruction or one more line of code. Let's write the setup instruction. How you will be modified when, like, how you will be notified when the 1000 microsecond is complete. That is timer overflow flag. So what I'm going to do, I'm going to check timer overflow flag. I'm going to check timer overflow flag. Now, the thing is, you do not know when this thing will happen. Okay. It will happen after 1000 microseconds, but you will never know when 1000 microsecond is completed. Okay. That means you have to do this task continuously. So this task is required to perform repeatedly. Okay. This task is required to do repeatedly. So how to do that? Like for example, let's say you called up your friend on the for some help, okay, one assignment help or for some question related to exam. So your friend told you that, yeah, I'll be sending you in a moment. Okay, I'll be sending you some document. You require some document, and I'll be sending that document in a moment. Okay, and he hangs up. Like now, what the task will do? You will wait for the document. Like you will take your mobile and you will wait for the either email or WhatsApp, whatever he's going to do. You will be waiting on your mobile for document to be received. So what you are doing? You are busy in checking the mobile continuously whether he has sent the document or not. Okay. So same way here, whenever overflow occurs, at that time you have to continuously monitor it. So you cannot check it with if. Like if I do it with if, what happens? See, okay. You may use if, but what happens with if is it only check once. Like your friend told you that I am sending you the document, you check your mobile, it didn't receive, so you put your mobile. It's not that way it works. But what you'll do, you will wait until you receive the document on your screen. Okay, so you will wait for that moment to come. Okay, so it might be take 1 minute, might take 5 minutes. God knows what happens. So you cannot check it using if. What will happen if you check with if? If can only check that thing once. But what we want is we want to check this continuously. Okay, until that moment arrives. Until that time, I want to check. So what I can do? I should use which thing I should use instead of it. If what should I do is I should use while. Now see up to what time I have to wait. Up to what time I have to wait for this example until and unless your TF is equal to 1. I have to wait up to this moment. Okay, TF0 should set, then and then I should be stopped. Okay, why? Because when TF0 set, that's the moment when your 1000 microsecond is completed. Okay, so how to check that? So what I'm going to do is while TF0 equals 0. Okay, TF0. Why TF0? Because I'm using timer 0. So timer 0 overflow flag is TF0. So I'm checking it with 0. Now the question might be, sir, why you are checking with 0? You should be checking it with 1. But what we are doing is we are waiting. Okay, what I am checking, if TF0 equal to 0, what I'll do? I'll come here again. While that means this loop will continuously execute unless your timer overflow flag set. If your timer overflow flag set, then and then what will happen? If my TF0 equal to 1, what will happen? 1 equals 0. This will be wrong, and immediately I'll be coming out from my loop. Okay, so this is the way of checking the loop. I'm going to write one more line of code over here. Okay, so let's write LED equal to 0. And here I'm going to do one more thing. I'm going to write LED equal to 0. This is just for our use. Okay, this is not a part of program that you are writing, but I want to show you something. Okay, so T more equal to 0x01 FC17, and then I'm waiting for TF0 to get 1. Okay, I want TF0 to be 1, that's why I am checking with 0. If it is 0, what will happen? The condition is true, again it will come and check. But if your condition is false in first place, immediately it will go out. That's why I'm checking it with 0. Okay, so keep that in mind. That's why I'm checking with 0, because I want this to be 1. Until and unless this is 1, I do not have any task to do. That's why I'm keeping that busy in checking the status of TF0. Okay, I'm going to run this program now. Let's see what happens. Okay, I'm adding a breakpoint over here, and I'm going to run this code. Okay. Now you can see here. So TF0 is set, and your TH0 and TL0 has reached to 0, 0. If you are not able to see it, let me show it to you. Okay, you can see TH0 equal to 0, 0 and TL0 equal to 0, 2. So starting from FC17, it has reached to overflow. It had been overflow, like overflow has occurred. Due to that, your TF0 set and your TH0 and TL0 has reset to 0, 0, 0, 0. Okay, like you can see 0, 2, but that's internal. That's why you are seeing it. Now let's check whether the desired delay is achieved or not. So I'm going to set up an LED over here. And now I'm going to run this code again by resetting it and running it. Okay, I'm going to zoom in all. And the next movement. So from this point up to this point, it should be 1000 microsecond. Let's check that whether it's correct or not. What you are saying is 0.3787 milliseconds. Is it 1000 microsecond? Is it 1000 microsecond? You can at least say no.
It's not 1,000 microseconds.
Yeah, correct. It is 378 microsecond and not 1000. And that's error is due to your assumption. What you have assumed is 12 megahertz frequency. And if you go here on target one, right click on target one, go into the options of target one, you will see your XTL is 32 megahertz. So set it to 12 megahertz. Okay, I am setting this thing. See this thing. XTAL. That's my frequency to my 8051. Okay, internally it was 32. Okay, by default it's 32. When you are running it on call, I am simulating on Gale, so I have to declare this frequency to be 12. That's why I am declaring it to be 12. Okay, and then I'm going to rerun this program and let's check what happens. Okay, I have run this code one more time, and now let's check what happens from here to here. What is the time now? You can see exactly it is 1.01. So that kind of 1 microsecond error can be generated, but otherwise this is the correct output. 1 millisecond. 1 millisecond is represented 1000 microsecond. So you can see I have generated the correct delay, but still this is not the correct program. We'll discuss the remaining part of the program in tomorrow's session. Okay, we'll stop here for the today's session. If you have any questions, you can ask. If you have any questions, you can ask.